Yes, sir, we can start.
Okay, sir. Hello. Good evening, everyone. I'm Aravind, a technical trainee at Wings of Aero. It is a glorious moment to extend my warm wishes on behalf of the Wings of Aero. I would like to explain about the TEMS era platform and our previous chief guests. TEMS is India's digital learning platform that provides advanced learning and research opportunities for science and engineering students. These are our previous courses. Dr. Dharmahendra Singh Chand, Professor and Head Aerospace Engineering, Chandigarh University. He was delivered his session Gas Turbine and Space Propulsion on our platform. Professor Jayant Murthy, Indian Institute of Astrophysics. He was delivered his session Robotics for Future Space Astronomy on our platform. Professor Prasanna Ramamurthy, Collins Aerospace Principal System Engineer. He was delivered his session on avionic architecture and data buses on our platform. So today our chief guest Muhammad FAHEEMUL Islam. First of all, I want to convey my heartfelt gratitude to Muhammad FAHEEMUL Islam, UAV System Engineer R&D at Tronics Technology Private Limited, Chennai, for accepting the invitation and presiding over the seminar on drone technology, principal application and advancements. The webinar was conducted and organized by Wings of Aero for the science and engineering students to gain insight and information that would remain effective in their research and projects. I will give the session to Muhammad Fahimul Islam. Sir, you can start the session, sir.
Hello, yeah, am I audible?
Yes, sir, you are audible. You can
Uh-huh.
start.
Okay, thank you. First of all, I would really like to thank Arvind for having me here, for contacting me and like letting me have this opportunity to uh, provide my experience, my knowledge through your platform. So I heartily thank you and the team who has organized this webinar. So with that, I would like to introduce myself to the people out there. So this is Fahimul Islam, uh, working at Aero 360 Dronix Technologies Private Limited, Chennai. So I have been working in this company for about 1.5 months. Sorry, 1.5 years. So with that, I have gained some experience, and then also I used to participate and work in various competitions, technical activities during my colleges. So with that, I had some experience through which I came to this platform. So with that, I have hopefully I have prepared a presentation for all of you, so that I can provide whatever I know to all the people present here. So going ahead, I'll be a uh, is my screen visible?
Yes, sir, it's visible.
Okay. So yeah, so going ahead, again thanking the platform Wings of Aero for giving me this opportunity. And as the session has already been titled, it's about drone technology, principle, application, and advancements. We all know about drones. We have heard it somewhere or the other. We have seen YouTube channels. We have seen them nowadays being used in various places as well. So since this is of a coming future of a industrial revolution that's coming ahead, like it is being used almost in every application nowadays, or have been thought of to be used in various applications, making things much more simpler and easier, which used to be much complex once upon a time. So going ahead, so during this session, I would like to discuss on the following things. So about drones, how are they classified? How are they recognized in India? Then what are the types of UAVs? How are they? What are the applications? And since I believe most of our audiences are from technical background, so we'll be also discussing about the principles of how it works, what are the parts involved in a drone, what are the recent advancements, how do you categorize a drone, like what drone you are making, or if you plan to make a drone of yourself, or you would plan to purchase a drone. So how will you categorize that drone, and what are the expected future of drones? What can we expect in the near future? How and what are the things you can expect in the market, and in which sectors the penetration of drones and its applications are more. So going ahead, what exactly are drones? We have been hearing a lot of it about
Sorry,
drones.
sir. Sir,
Hello,
wait, sir. Sir, we can't see your another slide, sir. Just change your slide.
is it visible now?
No, sir. We see only first slide. Ah, yes, sir.
Is it visible?
Okay, sir. Ah, yes, sir. No visible. So carry on.
Okay, I think is it visible now? If I change the slides,
Yes, sir. Yes, sir. No visible.
can you see the content page? Right, you can see the.
Sorry, sir. Actually, the slideshow is not working. You have pressed slideshow, right?
Yes, yes, yes.
Yeah. We cannot able to see the slideshow, but now it is changing. Slides are
O-
changing. That is why.
Okay, I'll just try it again. Maybe some error is there. Mm, is the slideshow working now? Can you see the differences?
Yes, sir. It
Yes, sir.
is.
Okay, okay. I think there was some issues with that. Okay, so going ahead, I think I'll just go back to the contents. So this is what I have planned to take about and inform you on this following sections about classifications of drones, what are the advancements, what are the principles of drone flight, how it works, what are the paths of the drones, and what are the recent advancements that we have seen in the drone field, and what we can expect from the drone market coming ahead, because it seems nowadays people are using more of technical advancements in drones. Not only drones, be it robotics, be it technology as a whole. We are trying to avoid most of human intervention into technology so that they can decide for themselves. So we'll just discuss and see what we can expect from this drone industry. So going ahead, what exactly are drones? We have heard of that term a lot. We have heard whenever it's become a normal commercial name right now, drones. So what exactly means? What drones means exactly? So if you can have a look in my slide, I hope it's visible. So the drones can be actually it's an abbreviation for dynamic remotely operated navigation equipment. So basically, it's an equipment that is used for navigation, that can be remotely operated by a user, maybe a computer, or maybe autonomously by some ground computer. So there are various categories of drones, namely unmanned aerial vehicle (UAV), unmanned ground vehicle, unmanned surface vehicle, unmanned undersea vehicles, and unmanned spacecrafts. So these are various categories of drones that we see nowadays. But most famous and known section is the UAVs. So the category of UAV has been of great focus and has been tremendously done research upon for various advancements. But that doesn't mean it's the only sector. There are various other sectors which are also explored for various applications. But since unmanned aerial vehicles can be used to address many applications, can be used for various operations, missions, whatever so it be, and the flexibility of motion, and the capability of going to various long distances without human intervention, that gives the privilege of a UAV. But there are other autonomous systems, like even nowadays we have seen in uses of nano satellites, or maybe other equipments being used, maybe by DRDO. You will be able to see in news, maybe ISRO itself. So there are various other categories, but the most focused category right now in the market is the UAV. So what does the UAV consist of? It consists of the UAV itself. There will be a ground control system that will be used to control that UAV. It can be on a remote space or in some line of sight of that drone itself. Line of sight supposed to mean that the person who is operating at the ground can see the drone himself, or maybe it could be from a control center very remotely placed that are controlling the UAV itself. I think most of you are aware of the Predator drone that is used by United States. It's a very famous drone, even shown many in movies and all. So you will be able to see that there is a control station where they control this uh, drone itself, get the footages of the what the drone is seeing, and take the decisions accordingly. So those are some use of drones. So going ahead, drones. There are nowadays there are various categories of drones. You can even get toys that are being used to play by small kids and all. There are even professional racing drones that are being used and various competitions being held. Those are mostly manually controlled by human beings, but there are smart drones that can take its own decisions with various computers, vision systems that is equipped with the drone. So going ahead, what are the pros and cons of drones? Like as we are going to go ahead, first the most important part is why do we need this piece of equipment, or what is the benefit of this equipment? Why should we focus on it, or should we focus on it or not? That is something of great importance, because no one would like to focus on a technology that doesn't give any benefit. So what are the benefits, and why is it gaining so much of attention, and why everyone is focusing on this drone aspect? Why are they trying in this various applications? So here we are going to just discuss of some of the points, not all. There will be definitely some more points as we explore, and as per the application field that is being used, there will be other aspects as well. But some of the pros and cons will be as follows. Like if we use a drone, they can be used for safe environment. They are cost effective technologies compared if you remember once upon a time when maybe in our 90s or maybe the early 21st century, we used to see photography or maybe even video shooting with people in helicopters carrying a big video camera. But nowadays that same thing can be achieved by a small drone with a small camera, but it is being used in various filmography, even in various surveillance operations or photography of that sort. I believe nowadays everyone has seen drones being circulating in weddings and all. So this is comparatively very cheap. You get a drone at the price of a DSLR, and you can do many amazing things with that. Then the quality of aerial imaging, like it's impossible for the footages that the drone can catch, it's impossible for a human to do the same. You will be amazed by the videos and the photos taken by drones. I believe you all have been seeing during our COVID situations, there have been people who have used drones to show some really beautiful images of our cities and how the pandemic has hit and everything. So those are some things which a human cannot do it by themselves, or if they use some expensive equipments. But with drone, those things are achievable. Then they are very precise. They can be used for precisions in various applications as well. Like drones are used in mapping and various other applications. They are easily controllable. Nowadays, you don't even have to know much about drones. You just it's very easy to control. It's just you take it out of the box. You know the basics of the drones, and you are good to fly with it. Then security. The drones are being used in multiple places by police, by armed forces, by defense, in various sectors for intelligence and for information gathering. And also they are being used in various industries, or for example, there, let us assume there is some nuclear leakages, or maybe some leakages in industries that are harmful for human beings to check. So you can just send a drone and see what exactly is going on there, and accordingly act on that same thing. So in-depth and detailed data in place. For example, nowadays drones are being used for mapping extensively, because previously the method for mapping was very expensive, which used to be in crores. But due to drones and this drone application, that same project can be done in just some lakhs. So there is a drastic difference and improvement in the precision of mapping. So therefore, drone has really penetrated well in this market. Then the flexibility in quick inspection. If you want to inspect a windmill, let us say a blade has been damaged. So for a person to go and inspect that blade, he has to make some construction, maybe some elevated platform or something. But with drone, you don't have to do a thing. You just have to unpack it, fix it, put a battery, and just you are ready to check these things. And similarly, hazardous areas, like I previously discussed. So the cons, yes, every technology has its pros and its cons. So here are some of the cons for drones as well. Privacy, like there has been numerous like rules given by the authority of India to prevent such violation of privacy, and so that people do not use drones and enter into private spaces and get informations which they do not should not, or maybe office spaces, or maybe restricted places. For example, if you all have known, then maybe it was quite a long time, but a drone was found to be roaming around the parliament, which was a really alarmist situation, because anything could have happened in that. So there are some legislative uncertainties about that. Like there have been various rules and regulations. There have been fluctuation in rules. Then comes safety. The most important thing is this piece of equipment is flying high in the sky. Let us assume some failure has happened, or it has crashed with a bird or something like that. It will come dead drop on a person standing at the bottom. So you can imagine, let us assume, even if it is a kg or a 2 kg equipment, it falls on someone's head, it can really cause some big damage. Not only human beings, maybe some private properties, maybe some cars or something. There are situations that could happen in that way. Then there are software malfunctions, which in general anyone right now, even while we were discussing, we had some software malfunction in here, where I was not able to show my screen and all. So it's a legitimate situation where there is technology and some software or something is running around. There can be such situations of software malfunctioning. And vulnerable situation with wild animals. Wild animals in the sense, let us assume it's a bird or something. It goes and hits with that equipment, so it will hamper the operation that you are using it. Spying, it has been many times used for that. Easily hackable, since it's a piece of equipment, it has a computer, it can be hacked. Then comes weather dependency. Let us assume there's a cyclone, there is rain going on, or maybe there's a windy weather. So it becomes very hard to operate a drone. Knowledge and skill. Now it's not like if you want to drive a car, it's not like you just can get a seat on the driver's seat and you can start a car. You need to have a basic knowledge and skill before you get the authority to the authority to drive a car. That same thing comes for a drone itself. You need to know the basics of drones, how the drone works, how you should control the drone, so that you can operate it. So a minimum level of skill or knowledge is necessary. Then comes data rate. That is also a problem, but which only when you know, when you fly a drone or work with a drone, you'll definitely get to know there are some problems with that as well. Going ahead, the type of drones. You have mostly seen the multi-copter one, which is visible in the screen, I believe. That most of the times it's been seen that drones or something is this multi-copter, but actually that's not true. There are various categories with respect to applications, what drones needs to be used, which one is good for what application. As such, there are various categories, mostly not many, but major category would be four. So in this are fixed wings. Basically, they are just like planes, but they are unmanned. They are, instead of a pilot sitting there, you can just control it with a computer and with a communication system. Like for example, Predator. Even we ourselves have fixed wing drones for defense. Then comes multicopter. That is drones that have more than one propulsion system, propellers. It can be 3, 4, 6, 8, 10, and so on. But normally, most commonly used are the four blade propellers, which you can see in the screen itself. So that category falls in the multicopter. Then comes single copters. Basically, this is a helicopter, but in an uh, unmanned approach. So the principle of the helicopter is the same in here as well, but instead of a pilot sitting, there is a computer that's working all of it. And then comes the hybrid VTOL. Now, for example, you want to use the benefit of a fixed wing, but also the benefit of a multicopter. The problem with fixed wing is it needs a sort of runway or maybe a launch platform to take off. But in a multicopter, it can just take off from the spot. Basically, it is called vertical takeoff and landing. So in hybrid, what we do is the benefit with fixed wings are that they give higher endurance. They can be used for covering large distances and can be used for longer duration compared to multicopter. So how do you use the best of both these technologies? So there comes the hybrid VTOL. That is, it also has, if you can see in the screen, they have this four blades in them, which are used for directly taking off from that landing spot. And then you will see that design is of fixed wing. So once it has taken off, it has reached the particular height, so it can carry on its operation like a fixed wing. So I hope these are clear about that. So coming to the classifications, in drones, right now drones, previously drones was independent. There was no governing body looking into it. But right now in India, there's the DGCA that is looking into the all the rules and regulations, all the registrations for drones. Nowadays in India, you cannot fly a drone without registering it. Just like a car, we need to register a drone, be it a toy, be it the most expensive drone that you have. So without registering, that drone is considered to be illegal. So where do you do the registration for all those drones that you have or are planning to have, or maybe you want to make your own drone? Where do you register the drones that you have? So DGCA looks into this thing. DGCA is Directorate General of Civil Aviation. They have been there for assessing various incidents with aircrafts and everything, rules and regulations, licensing for aircrafts that are flying in India. So along with that, they have also taken in the category of drones. So right now, as per DGCA, the following are the categories that they have classified. So they are nano, micro, mini, small, and large. So I hope in the screens you are able to see that how they have been classified with respect to weight. So right now, all of this category needs registrations, but different category has its own classification methodology of registrations and all. Let us assume you have a nano drone, so the registration is completely easy. You don't need much of a thing. But if you go for a large drone, then there's the registration is definitely going to be hectic. Going ahead, we already have seen the various types of drones. So what are the various advantages and disadvantages? How do you use in which applications, what are to be used? So if you can see, uh, the benefit of multicopters is accessibility. It's very easy to use it. It's easy to use. it can hover during flight. So for example, if you have a fixed wing, it will not hover in a place. It is a constantly moving equipment. But for a multicopter, it will be stationed in one place. So if you do not want to control the drone, or you want to monitor a single object, then it will just hover at that place, and you can just focus on the scene, or maybe the object of interest. So that facility is given by the multi rotors. Then it has good camera controls. Some of the best cameras available in the market for drones are being used with multicopters. Then can operate in very confined areas. I believe you all have seen people even fly drones in their homes itself. So that is possible with multicopters, which is not possible in any other category of drones. But the disadvantage with multicopters are because they are using 4 motors, so they need a lot of power, due to which there's very less flight time. You cannot fly a drone. Mostly available ones in the market is hardly you will get 20 to 30 minutes of flight time, or even less maybe. And also they do not have high payload capacity. For example, you want to deliver some heavy thing, or you want to carry some heavy load, that is a little difficult in the multi-copter category. Then they are mostly used in photography, inspection, surveillance, and such sort of applications where camera is of major focus or use mostly. Now next, going to we have fixed wing. Like I said earlier, fixed wing, since it has one motor and it hardly needs much of a propulsion, so it has more flight time. So you can expect for the 2 hours, 3 hours of flight time with fixed wing, which is not possible in a multi-rotor. Then it can cover very large areas. Suppose you want to do mapping, or you want to investigate a big pipeline or something, or maybe a solar plant. Then this is possible with fixed wing much easily, because you have more flight time, as well as you have the speed to cover maximum area. But the disadvantage with this drone is that like I said earlier, it needs a launching space. You just cannot like multicopter, you cannot just take off from a specified area. You need a launch platform, you need a runway, or maybe a equipment that can push it directly into the sky, or maybe you have to push it with your hand itself. And it's harder to fly because it's a completely moving equipment. It won't if you make a mistake, it will just go and hit on something. And also they are expensive, because unlike multicopter, they are mechanically more complex, because they follow aerodynamics more than multicopters do. Multicopters, you can just collect any materials that you have in hand and go ahead with that. But that is not true for fixed wing. In fixed wing, you need to follow aerodynamics like very strictly, because the CG, the shape of the body, the material used, those things matter a lot in the performance of the fixed wing. So as said, the following are the uses of fixed wing that you can see, that is mapping, pipeline, and power line inspections. Then we go to single rotors. Now the question comes, when we have multi rotors and fixed wing, why do we go for a single rotor uh, drone? So single rotor has some benefits which are not possible in either of the two categories that we have discussed. First of all, it can take off from a specified space, just like multicopter, and hover like them. But with that, since it has a single motor compared to multicopter, multicopter has minimum 3 to maximum 8 motors that has to be used for it to take off and fly. But in a multicopter, it needs one motor for flight, and one motor that is that is at the tail of it. Most of you have seen it in helicopters and all. It is used for the stability of the helicopter, and to prevent the reaction force that is generated by the motor that is used for flight. And the capacity of single rotor are more compared to multicopter, because it has larger propellers, so it has more lift compared to multicopters, so it can be used for heavier payloads. But they are comparatively much dangerous because of the same reason of big propellers and since if one propeller breaks, there's nothing to have a backup for. Like such is not the case of multi-rotors. There are provisions. Suppose one propeller breaks or a blade breaks, we can still stabilize a multi-rotor, but that is simply not possible with a single rotor. So it is harder to fly and comparatively much expensive. But they are used for various heavy payloads like lidar, laser scanning, etc. Then comes the fixed wing hybrid that we have already discussed. Basically, this is to achieve the best of multi-rotor and fixed wing, but it has its own limitations. That is, there are if you go into the physics of this itself, there are problems during hovering and flight, because since it has to be aerodynamically good, which is not compared to fixed wings. It's not that of an aerodynamic design, but again, if you consider from multi-rotor, it is harder to hover fixed wing drone compared to multi-rotor because of its design complexity. So this category is still under development, but many have been looking into it and exploring how to use this for various applications. So coming to what are the applications of drones, where we can see the drones right now. There have been the drone industry has penetrated into various applications, due to which it has gained so much popularity in recent years. So speaking of some applications, it is defense, police force, coastal guards, agriculture, firefighters, disaster response force, forest and wildlife, delivery, industries, photography, security, and transportation. So I believe nowadays you all have seen somewhere or the other in these applications, you have seen drones being used as such. So going ahead, what are the principle of the flight of a drone? How does this, as being, I believe the majority of the our audiences are from technical background, so it's very necessary for us to know exactly how does a drone work, how it operates, does it fly, and what are the physics involved in a drone. So if you see in the first picture, you'll see there are four forces that are responsible for a flight of a drone or maybe an aircraft as a whole. It's not just the drone uses the same principle of an aircraft. So the aircraft, for it to successfully fly, there are four forces that needs to be addressed upon. That is the weight of the drone, weight of the aircraft itself. That is weight due to gravity. To overcome that gravity, there is the lift force that is achieved either by the shape of the wings, that is the airfoil shape of the wings of a aircraft, and for a drone, it will be the shape of the propellers, which we'll be discussing ahead as we go through this webinar. So then comes the thrust force, for the force that is required to make the aircraft go forward, and then there is the drag force. I believe all of us are aware of the drag force, that is any moving body that is moving in a fluid. The resistance that is faced by that body is called drag. So to overcome that and also to propel the aircraft ahead, we need the thrust force. So these forces are in general applicable everywhere, in any equipment that you want to fly, be it rocket, be it aircraft, be it a drone. So any equipment or any medium that is supposed to fly will be working with these forces as a whole. Then comes the basic dynamics. If you see the bottom left picture, you'll see something called roll, pitch, and yaw. So these are the three axes, that is rotational axis, of which the aircraft or a drone operates. So these are the fundamental axis and also the axis through which you can control the motion and the flight path of a drone or an aircraft. So they are as pitch axis, roll axis, and yaw axis. So the pitch axis is basically, let us assume, uh, you must have seen an aircraft trying to take off or land. So the axis at which it rotates to tilt up or down, that is called the pitch axis. So the pitch axis is basically the rotation done on the let us assume the x-axis. So if you see in the left right picture, you will see the pitch axis, that is the rotation at that axis. It is called pitch. Then you will see the vertical, sorry, the horizontal axis that is facing at the nose of the aircraft, that is called the roll axis. So you want to make the drone or the aircraft go left or right. So how do you go about it? So the rotation that you will be doing to achieve that following movement, that is called roll. So you want to go left, you will roll to the left. If you want to go to the right, you will roll to the right. Then comes the yaw axis. So you are flying ahead, but you want to turn the aircraft or the drone. So how do you go about that? So the motion that is used to achieve the rotation at that axis, so that you can turn around, that is called the yaw axis. So you want to turn to the left or right, you will yaw to the left or yaw to the right. So these three motions are very crucial in controlling the drones that we have. So even the basic drone that you have, you will get a remote controller. So how do you control the drone? So like in a car, you will have accelerator, brakes, and clutches. So here you have the same thing, but in this case you have the pitch, roll, and yaw. So you want to go ahead, you will, in the car you will press the accelerator. Here you will go use the pitch. If you want to turn left or right in a car, you will use the steering. Here you will use the roll axis. And you want to turn around, then you will press the accelerator and then the steering itself. Here you will use the yaw axis to turn around. So going ahead, like I already discussed, what how does a aircraft fly? So the most crucial design that has really made us achieve to fly, it is the aerofoil shape. This is the shape that has been used in aircraft wings. It has been used in propellers of our drones for to achieve lift. So this shape is very crucial for us to lift our drone or aircraft. So this action is basically related to the Bernoulli's principle, where if you remember, if you recall with me, that with increase in velocity, the pressure decreases, and with decrease in velocity, the pressure increases. If you focus on the uh, right top picture, you will see how the uh, bottom flow of air is slower compared to the air that is moving on the top. At the same distance from the tip of the airframe to the back behind of the aerofoil shape to the behind of the aerofoil shape, you will see the bottom airflow is taking lesser time. It will take a lesser time compared to the air at the top. So the air at the top will try to reach the back of the airfoil shape faster, due to which there is increase in velocity of the air on the top, and there is decrease in pressure. So since there is increase in pressure at the bottom, and in this results to a upward force that has been acted upon on that airfoil shape, due to which we gain lift. So the faster this the bigger the difference between these two velocities, the more lift we gain. So there are a lot of experiments still working on how to improve this shape itself. So the faster the speed we achieve, the more lift we'll gain, and we'll be able to achieve lift. Now the fundamental it's not just like you just achieved some pressure difference and you are good to go, and your aircraft will just lift on from there. The most important part is the weight of the drone. When your lift force is more than the weight of the drone or the aircraft, only then can you see it lift. So when that lift force that has been generated is more than the weight of the equipment, then you can expect the equipment to lift up. And that is why it's very crucial for the aerospace industry to look into the weight. There's always been a lot of concentration on how to bring down the weight of an aircraft, how to bring down the weight of a drone, how to keep it as minimalistic as possible. It is due to which that to keep the weight as low as possible, so that with minimum lift we can take off from the ground. So this if you would see a bird, if you take a bird compared to the flight it does, it's very lightweight. So that same, due to its lightweight, with less velocity it can just lift off easily. So that same thing has been inspired upon and worked on in the aerospace industry. Now there are various configurations of drones. You may have seen there are some drones with only four propellers. Some you will see with only three. Some you will see with six, even eight. So what are these configurations basically? Why do we need so many blades as first place? And if you see on the left picture, you will see that the motors are not all rotating in the same direction. Why is it so? So it is because if you know the principle, the third law of Newton, every action has an equal and opposite reaction. Now let us assume all the motors are rotating in the same direction. So there will be a same force, or to be more particular, same moment at one direction. Let us assume all the blades are rotating clockwise. So what will happen? There will be a resultant anti-clockwise moment because the action is in clockwise direction, and the reaction should have been there, and that will be in the anti-clockwise direction. So your drone will not only lift off, it will start rotating in the anti-clockwise direction also. The whole drone will start rotating in the anti-clockwise direction, and you may not even see the drone lift off. So that principle has been countered in helicopters. If you see in helicopters, it's not always one fan that is on the top. You will need a tail rotor to compensate that reaction force. But how do you go about in a multicopter? So in a multicopter, it is achieved by the following thing. If you see carefully, you will see that two of the motors are rotating in anti-clockwise direction, that is B and D, and two rotors are rotating in clockwise direction, A and C. So what happens is the two reaction force that is exerted by B and D is compensated by the reaction force of A and C. So there is a resultant zero reaction force, due to which that reaction force has been cancelled out, and you can only see the lift being achieved. So it's so well engineered that if you want to go forward or backward, or you want to roll at the sideways, which we'll discuss in the coming slides. So due to this configuration, there is no such problem of moment as of such. But moment is also necessary. For example, you want to turn the drone that you see in the picture on the left top corner. You want to turn it a little bit on the right. So how do you do about that? So you rotate, you make sure that the resultant force is a little bit higher on the clockwise direction, so that the drone rotates in the clockwise. So you will be able to achieve a turn in that direction. So you can make your drone turn to the right. So that is achieved by rotating the anti-clockwise motors a little faster compared to the clockwise, so that you get a clockwise resultant. And then you will see your drone rotate a little bit on the right side. So the picture on the right that you are seeing that's moving around, that is called the X configuration, because obviously if you see the airframe or the structure of the drone, it is in an X sort of a configuration. And there is also the plus configuration because of the shape itself. So any drone that is using 4 blades are called quadcopters. Quad meaning 4. If there are 3 rotors, it's called tricopter. Then if you see in this picture, this drone is using 8 propellers, so they are called 8. So octa plus, this is the configuration. Octa X is the configuration. Octa square plus, octa square X, octa collinear plus, collinear X, coax plus. Now coax is basically coaxial. So you have four arms itself, but in each arms you are placing two motors with propellers. So this is also to achieve more lift and to be able to achieve more to be able to lift more heavier payloads. So this is coaxial plus, octa coaxial X. Then we have hexa, that is 6 propellers. Hexa plus, hexa X, hexa H, hexa coaxial, and hexa coaxial reverse. So these are the general configurations of drones. So if you ever want to make a drone and you want to explore which configuration to go about, these are the some general configurations you can look into. And the most commonly used configuration is the quad X. Then I believe you all have seen that most of the drones that you see in the market are using the quad X because of its simplicity basically, and more effective maneuvering compared to quad plus. Now we go to the motion of the drone. How does a drone like go forward, backward, left, right? How do you achieve that? What is the mechanism behind the thing? So if you see on the top left corner of the picture, you will see there is a suddenly the one side of the motors are, the arrows are becoming a little bigger. That is because that motors have been the rotation of those motors had been increased, due to which we are getting more lift in those arms, due to which if you see right now there is a difference in forces between the 4 arms. Like for example, if you want to roll on the left side, so the roll on the right side, so the left side will have to give more force so that it tilts in that direction. So moment will be created. Let example, for this pitch action, the backward motors are rotating faster, due to which more lift is generated and is tilting at the front. And now if you see from the roll side, the left side of the propellers, the rotation will be increased, and the force due to which increases, and it will tilt on the right side. So this is how pitch and roll is achieved. But how does it facilitate the motion of a drone? Now if you see at the bottom right picture that is available, you'll see how the resultant force is acting to compensate the thing. If you see this picture now, it is one force is generated in this direction. One force is compensating the weight of the drone, and one additional force is generated, which is at the direction of the motion. If you see carefully, you will get to see it there, that the green one, that is it is used to compensate the drone, the weight itself. And now if you tilt it, this this force will compensate the weight, and the other force will be used for moving in that direction, if you can see in this picture itself. So that force is the motion force. That force has to be more than the drag force of that equipment or the drone itself. Like the resistance caused due to the motion of the drone, that force has to be more than that. Otherwise, like for example, friction, if your force is not more than friction, you will never see a car go forward. Same thing happens for a flying equipment itself. The force for motion has to be more than the drag force that is being exerted on the drone itself. Only then can you see it move forward. Same thing as it was in lift. In lift, if the force is more than the weight, only then can you see it lift off, else it will just stay in the ground itself. So I hope I'm able to picturize how the drone works and how it is able to move in various directions. So if we go into the parts of the drones now, as we are know how a drone works, how do we go forward, backward, left, right. We know how to steer the drone. Maybe we soon all of us will become expert in that as well, and we'll see people from our audiences join the drone racings and everything. So we are good to go with the basics of drones. We can now fly a drone, but how do you make a drone? Now let us assume you want to participate in a racing competition or drone racing competition, or you just want to make a drone so that you can take a selfie of yourself. So how do you make a drone? What are the components needed for you to make a drone? There are many cheaper, many costlier options available. So the drone consists of majorly these five parts. These are the major parts of a drones, but it is not limited to them. There are many other equipments that are used nowadays. But to get a basic drone that you want to take a selfie of yourself, what will you use for that? So for that, it has some mechanical parts. It has the propulsion system, the avionics, that is how the electronics that is involved for the aviation of this equipment. So it's called avionics. Then the communication. How do you the wirelessly you have to fly a drone? You cannot expect a wire being connected to a drone. Then you will be limited to make it fly, or maybe it will get tangled in some propeller and then you will see it crash there itself. So definitely it has to have some wireless system to talk to the drone so that we can move it left and right, take a picture just by clicking a button. Or you want to go some 1 kilometers, 2 kilometers away, then definitely you cannot expect a wire to be that long. So how do you go about it? There are various technologies, like we all know the electromagnetic waves, radio waves. Then like most of us, we are using Bluetooth, Wi-Fi, even the phone that we use. So the drone uses the same thing as well. Then we have the payload. It can be some camera, it can be some hook system, or it can be anything. Let us assume some defense. You want some defense person wants to put a gun in that drone. So that gun itself becomes the payload for that drone. So going ahead in more details of those components. So the major components are in mechanical section are the airframe. So airframe is that skeleton or that overall casing that encloses the whole important parts of the drone. You, for example, the motors, the electronics that you want to put inside, the battery. You need something that can hold the whole thing together. So that thing is called the airframe. So you can use various materials for the same, but definitely if you remember from our previous discussion, it has to be lightweight. So mostly nowadays carbon fiber, aluminium, or glass fiber or composite materials are used for the same. So that if you all know the characteristic of carbon fiber, they are lightweight but stronger than steel. So it's very apt for the such an application for drones, as you want to keep the drone very light, but you need it to be strong enough so that you do not, just because of one crash, you do not lose your drone. So carbon fiber is generally used. Then we have aluminium, then other composite materials like glass fiber, etc. And then comes the landing gear. Landing gear is anything that the drone lands upon. Now your drone has taken off, but it definitely has to land. It's like it said, it's not the flying that hurts, is that landing that is most dangerous. So like in aircraft, it is not the flying that is most dangerous. If you cannot land properly, then definitely it can be disastrous. So that's why this is a very crucial mechanical part. It has to be lightweight, but it has to be very strong, so that even let us assume there's a failure, the landing gear can compensate and maybe protect still the aircraft, or maybe the people inside it. Or in case of a drone, maybe you have kept a very expensive camera or some equipment that you want to transfer from one place to the other. For example, you are carrying a COVID vaccine from one place to the other. That's a very expensive thing. Suddenly a bird comes and hits your drone. Now what do you do about it? So maybe the landing gear is good enough to save that vaccine out there. So it's very, it may be a very, the drone doesn't have mostly multicopters. They don't have many of mechanical parts, but whatever mechanical parts are there, it definitely has to be very good. And if it is a fixed wing, then it has to be aerodynamic completely, so that the drag is reduced, and that is achieved in less weight. So if the drag is reduced with less force, you can achieve higher speed. So therefore, and also the aerofoil shape that needs to be followed, due to which the lift will happen. Otherwise, it's impossible for a fixed wing type of drones to lift off. So then comes the propulsion system. The propulsion system consists of the motor, the controller, the electronic that controls the rotation of the motor, and the propellers itself. So if you can see, the mostly in drones we use the BLDC motors, that is brushless DC motors. Now in the next slide we'll talk about why we use brushless DC motors and how it works and everything. Then what that the electronic speed controller. So this controls the speed of the motor. For example, as you have seen in the previous slides, you want to go forward, so you will pitch forward. So to pitch forward, you will increase the rotation of the back arm motors. So to do that, that instruction will be given by the electronic speed controller. And then we have the blades, propeller blades. Generally used are the two blades, but there are also 3 blade, 4 blade, 5 blades. Now you must have seen mostly the racing drones use 3 blades. So I leave it up to you, and maybe you can explore as well from your side why racing drones use 3 blades, and why the general commercial drones are okay with 2 blades itself. So maybe you can look into that thing as well. I leave it up to you, so that your curiosity on this thing maybe will help you to drive to find why exactly this thing is out there. Now coming to the BLDC motors, that is the brushless DC motors. I believe we all have seen from our class 11, our plus 2 courses, that we know about the principle of motors working. But if you remember, in those working principles, there was a thing called commutator, and there was a thing called brush. So if you recall the principle correctly, there is a contact part that needs to keep contact and change the polarity of the motor. Only then the motor will keep rotating. But this thing has a problem, since it's something that needs contact, and it's not a fixed contact, it's a rotational contact. Like if you see in this left bottom corner picture, you see this thing would actually rub to this part of the motor. So with time it will start wearing off, and it will not give a very high life of the motor. And since in the drone you would not want it to fly only once or twice, you definitely want to fly it more than that. Plus you want to fly it for a long time, you want to increase the speed. In brushed motors, what happens is, due to this friction, there is generation of heat, and due to generation of heat, the performance of the motor will be hampered. But you definitely don't want to have that. And as well, along with that, due to friction, there will be additional noise. So how do you go about it? So due to these disadvantages of brushed motors, the brushless motors have been invented. So the brushless motors are basically motors that have no contact with each other. uh, so like mostly it's a limited contact, it's not like there's nothing at all contacting. But the contact, the problem that we have faced in brushed motors have been uh, like removed from brushless DC motors. So in brushless DC motors, there are coils, if you see. So here we have permanent magnets that will be north and south. So uh, if you check these, the principle, the photos of this thing, how it is working, you will see there are 6 coils in the top left. There are 6 coils. So, and there is a north pole and a south pole. So basically you have to attract and repel that north pole and south pole, so that the overall, the top cowling of this motor keeps rotating. So in this case, you do not actuate the all, you do not power all the coils at once. There are some configurations to power this motors. If you see in the bottom right picture, so you see in this, let us assume this one as one coil. This, the red arrow one is actually one complete coil set, and the blue arrow one is another coil set. So this coil set is powered in such a way that it will repel this permanent magnet from it, and this coil is powered in such a way that it will attract the pole towards it. So once this repulsion is completed, and once the attraction is completed, the coil's powering will change. For example, like now, the once this permanent magnet reaches the blue area, the blue arrow area, the next power up will be the red one will be powered in such a way that it attracts that magnet, and the one which you see there is no arrows right now, that coil will be powered to repel that magnet. So in this case, this process keeps on going, so that the motor keeps on rotating. If you focus on the top right corner of the corner picture, you will see 3 graphs are there. So there are 3 coils basically, A, B, and C. So if you see the powering, the graph carefully, you will see that bottom arrow line, that is the zero line. In that, what happens is, in that line there is no power given to that coil. So there are 3 coils. So here the A and B is powered up. So you will see the simultaneous effect happening in this motor itself. So the A will attract it, B will repel it. Then A stops, B and C powers up, like how we discussed in the bottom left motor. After that, CA will power up, then AB, BC, CA, and it will keep on going like that. And the frequency at which this will happen will determine how fast the motor is rotating. There are also motors, if you can see here, are only 3 coils or 6 poles. In some motors there will be more than that, for more better speed, more accuracy, and as such better performance of a motor. So this is just a brief explanation of how BLDC works, but there is a whole lot to explore in this thing. So if you check out more on this itself, you will get to know about the working of motors itself. And it's very important to know about motors, and also the selection of motors, because they are the deciding factors of whether your drone is about to fly or not. So what is the rotation you require, what is the speed that you need, the torque that you need from that motors, those are the most crucial parts to determine whether your drone is going to fly or not, and how it will perform. So going ahead, how do this coil switching happen? Like, as you have seen, who decides that A and B will be switching on, then again B, C will be switching on, then C, A, and at what speed that needs to be done? Because if the synchronization doesn't happen at the right time, then the motor will not rotate, it will just get stuck somewhere. So this has to happen at the right time, at the right moment, and the right speed, or else the motion of the motor will just stop in there. So this is done by an electronic speed controller. So the speed controller decides. It's basically a sort of switch. If you see at the bottom right corner, you will see that basically it's a switch. You see there's a change in switching due to which the coils are getting powered separately. So once the A and B will be powered, then the B and C will be powered, and then the C and A will be powered. So this switching is done by the electronic speed controller. So there are various electronics involved in this itself. This itself is a whole complete thing, a topic on itself. So how it works, what are the electronic things, and how to make an ESC. Definitely there are ESCs in the market, but how do you know which one to select, and what is the working principle of an ESC? So it's basically a switching method, and also how fast the switching needs to happen. The faster the switching happens and with the right frequency, the faster uh, the motor will rotate, and how much current has to go through it, that is decided by the speed controller. And that instruction of how much the speed is, that needs to be done by the microcontroller that we have, that will instruct accordingly. So this is just a glimpse of electronic speed controller. You can get more about it as you go ahead. So now comes the avionics, that is the aviation electronics. So you have your propellers, you have your electronic speed controllers and everything. So how do you now you need to make the drone fly, because there is no pilot sitting in that drone. There has to be some equipment, some electronics that can do the same. So this is done by the avionics system. So the avionics majorly consists of the flight controller, that is the control system basically. Then the inertial measurement units, the IMUs that we normally say in this. Then there are companion computers, like you will Raspberry Pi or maybe Intel Edison or something of those sort, that are used for better performance and computation, for better accuracy or precision of the drone. So going ahead, the flight controller. So what is this this equipment used for? So what is this electronic flight controller used for? So let us assume you are flying a drone. You are not controlling it right now. It's hovering at a particular position. Suddenly a wind comes and then pushes the drone at a particular angle. So for you, it will be difficult to adjust all the time to make it hover. To compensate that human error and to make it much more autonomous and easy for us to fly, we use the flight controller. So what the flight controller does is, if you see in the picture on the left top, let us assume the wind has given an error angle of theta. So now what the flight controller will do is, it will instruct the motors so that it can compensate that error angle that has been occurred. So it will increase the left side of the force on the left side, and then balance it accordingly so that it can come back to its original position. The flight controller not only does that, but if you want to pitch, roll and yaw, so it will decide which motors is going to rotate in which way, so that this particular action is achieved. So let us like, if you, for example, you have a pole in your hand, you want to balance it. So for you to balance it, it will be much difficult. That same thing goes for a drone itself. It's very difficult for a human being to control the motion of the drone without a flight controller. But with a flight controller, it's very easy. So you want to hover in a position. Nowadays, various advanced flight controllers, you won't even see the drone move around much. It's very stable. The stability of a drone depends on what flight controller you are using. So if you see in the bottom right corner, how does it work? So let us assume with time suddenly a wind has blown it, and it has given an error angle theta. That error angle theta will that flight controller will detect the same. There are various sensors to do that, that we'll discuss, that we have already said it's IMU, that we'll discuss in the next slide. So the IMU will say to the drone that it has tilted in particular angle theta. So what the flight controller will do is, the flight controller first generate a speed to counteract that error. If the flight controller doesn't do that, the drone will just flip in that direction. So it will flip and just fall down. So the flight controller will counteract that speed, then slowly it will cancel out that speed, and now it will give a reverse velocity so that it can come back to the position. But that reverse velocity needs also to be controlled, because if it gives too much, then the drone will keep on oscillating left and right. So it will slowly increase the slowly start decreasing the velocity once to in that position, so that when it comes to the particular theta of 0, there will be no inertial force, or else it will keep on oscillating forever. So a good flight controller will always try to do that, and that is, while it is compensating, it will monitor its position and slowly decrease this counteracting velocity, angular velocity, so that it can come back to its right place. So you can see how with respect to graph, how it is counteracting with respect to time. So you can see how the theta is changing with respect to the angular velocity itself. So this is done by a flight controller. Going ahead, now how does a flight controller know in what position it is? For that, there are various sensors to do the same. So in general, a drone uses the following sensors, but there are also people exploring more on how to improve and what are the sensors, more additional sensors to use for better navigation and better control of the drone, so that the flight controller can get accurate information and act upon them quickly. So there are gyroscopic sensors, accelerometers, magnetometers, depth sensors, and optical flow sensors. But in general, nowadays, mostly the drones are using, like for example, the basic drone will be using the gyroscopic sensor and accelerometer. And with that, there is magnetometer, so that it knows in which direction it is flying. So basically, we all know about magnetometer. So even the compass that we have in our phone, that is also using the same. Even our phone has accelerometers and everything, so that when uh, you rotate the phone, or you just like you want to switch on the torch, you'll just flick your phone twice. That is sensed by the accelerometer. So rotation is sensed by the gyroscopic sensor. And the direction, the compass, while you're using Google Maps, you're going to the north or the south, that is decided by the magnetometer. So this is the basic view of what this is like, the most sketchiest explanation of what these sensors do exactly. So if you see the accelerometer, this is something of this sort. So what happens is, let us assume there is a quick acceleration in the x-axis. So the sensing axis, let us assume the sensing axis is the x-axis. So whether that acceleration is happening at the positive x-axis or the negative x, that is decided by this accelerometer, and that happens with this principle that you are seeing in this picture. So it is sort of a spring system. So it detects in which direction the body is moving. Now comes the gyroscopic sensor. Gyroscopic sensor senses the rotation of the equipment, whether it is it's rolling, pitching, or yawing, and what is the axis. For example, in the previous in this, you could see that this drone has rolled. So if the flight controller doesn't know that it has rolled, then it will not be able to counteract the same. So this instruction is given by the gyroscopic sensor. This tells the flight controller that you are in this rotation, you are in this axis that you are rotating, etc. So this sensor senses the following. Then comes the magnetometer. So the magnetometer, for example, you are planning to go to a location, suppose the northwest side or northeast side. You want the drone to face northeast. How do you, let us assume after 2 kilometers you have gone, you cannot see the drone from your position. like 2-3 kilometers far, or you're flying it at a very high altitude, you will not be able to see the drone. Then how will you know that in which direction it is going? So this magnetometer tells you that it is going to the north or northeast, it is facing to this direction and everything. There will be a software in your laptop that will be showing that it's in this direction, so that you can still maneuver the drone without difficulty, which will not be possible for you because the drone is completely out of your sight. You do not know where is the head and tail of that drone. So this magnetometer will tell you the direction of where this drone is heading. So now we have the communication system. I hope that was the basics of the flight controller and the avionics. So moving ahead, now your drone is ready. You have all the sensors, you have all the flight controllers, you have selected your motors and propellers. So your drone is ready to fly. But like we already discussed, you cannot put a wire to control your drone. It definitely has to be wireless. So how do you take about it? So for that, you need a good communication system. So there are various communication systems for that. If you can see in this picture, one is called the BLOS and the LOS link. The BLOS is beyond line of sight. That is, you cannot see the drone from your position, but you need connectivity still. So for that, you use satellites or some internet connectivity of that sort. But you want to fly a racing drone, you don't need a satellite to fly a racing drone. You can go about with a simple controller. So that controller may use technologies for that, and that is called the line of sight link. That can be through Wi-Fi, that can be Bluetooth, that can be radio waves, the simple radio waves. So with that, because Bluetooth will give you a particular range, it will not give you more than that. Same is for Wi-Fi. So in this range, you can operate your drone. So beyond that range, if you want to operate, then you need a more sophisticated communication system. So in general, you can do that with internet, IoT based system or something of that sort, or maybe like how the defense and all have been using satellites to do the same. So in areas where internet connectivity is not there and you are not able to connect with your system, so for those type of applications, satellite communication are also being used in this. So this is the base, like this is how you'll go about with selecting which communication system you need. Definitely, you'll, if you are making a hobby drone or a drone for your racing, you'll not go for a satellite communication, that is out of choice. So you'll go for a communication system that uses Bluetooth or radio waves of other frequencies for the same. So that is about the communication system. Then comes the payload. The most important part, if not the drone, is the payload, because you have a drone, it is flying around the sky. Now you are for racing drone is fine, but that is not the main objective of a drone. Like once you are bored with making the drone fly, now you are planning to use it for some particular application. So what are the applications and what are the type of payloads that has been used in this application? For example, you want to do photography, you will put a camera. If you want to do some surveillance, you will put advanced cameras, maybe thermal cameras or something of that sort. You want to save a person's life, you will put a life life jacket or something of that sort in that drone. If you want to deliver some pizza from one place to the other, you will fit a pizza box in your drone and then send it from one place to the other. So with respect to application, here are some of the things that you'll see here. If you see this screen, so with respect to application, for example, mapping, there are photogrammetry, lidar, magnetometer. For security surveillance, EOIR based payloads, that is optical, electro-optical or infrared type sensors are used. Then VDAR, I hope you all know about LiDAR. So VDAR is visual based sensor, in which the LiDAR is laser based. So for industrial application, you can use a gas sensor or a visual thermal camera. So whether a gas is leaking, you can get to know from a gas sensor itself. So let us assume some harmful gases are leaking. and it is very dangerous for a person to go there, then you can put a gas sensor in a drone, make the drone go there and inspect whether there is any gas leakages or not, and in which you are not risking any human life, and the drone is also not at risk because the gas is not going to hamper anything for that drone. Then for delivery purposes, you want to deliver pizza or you want to deliver some vaccine from one place to the other, you will have various delivery packages or mechanisms for that same. Now comes the defense. Now defense uses not only these cameras but also various other payload systems like radar, then automatic identification system. You want to identify whether there's a weapon, whether there's a terrorist standing there, so you'll use such a thing. Then synthetic aperture radar system, visual and thermal camera, transponder. For example, you need a communication system, a temporary communication system you want to establish. You have no towers, so you can use a drone as a tower itself to increase your communication range. For example, you want to use a radio based telephone or something, you want to contact a base, and suddenly in that some terrorist has destroyed the tower, so you are not able to contact that base. So you can use a drone, you can establish a temporary sort of a tower with that drone itself. Basically it will compensate that tower, and you can communicate with the base again. So this is one of an application used in defense. Then comes agriculture. Now agriculture, if you have seen abroad, people before used to use aircrafts to spray pesticides in their field. But aircrafts are expensive and not everyone can afford it. And let us assume Indian agriculture. You just cannot think of a farmer in India purchasing an aircraft. So how does he do about that? So he can still opt for a technically advanced solution, that is use a drone completely and achieve the same pesticide efficiency that an aircraft, maybe better than an aircraft would do. So also you can use it for seeding in your agriculture, or even nowadays it has been used in areas that has faced deforestation. So various organizations are planting seeds or plants, small sort of plants using drones itself. So you will be able to see a lot of that in uses nowadays. Then comes photography, that is the basic drone application that everyone knows about. So using 4K 6K camera or some cinematographic camera with a drone for some exclusive shots that is not possible with any other equipments, so that you can do with a drone itself. So payload is a very important part of a drone that decides in which application you want to use a drone. So therefore a drone itself is nothing without a payload. So with a payload it will be deciding which application it can go forward with. So going ahead somewhat, we can discuss about what are the recent advancements in drones. We have already seen, we have seen some cameras and all. Is that the end, or what are we seeing right now that drones have been used? Some recent researches that are going on in the drone sector. So first of all, most drones are powered by batteries. Now batteries have their own health environmental problems, and along with that it needs charging, and along with that it has various other problems like it cannot give some good amount of flight time, everything. So people are working on other options to see whether we can power our drones with some other some other options. So some of them are hydrogen powered drones. There are also some engine powered drones, but engine powered drones again has its own environmental issues and all. But if you ever are interested, then engine powered drones can be used for longer flight times, to 2 to 3 hours. So let us assume you have a multi-copter, you want to fly it for 3 hours. That is not possible with a battery, but with a engine based drone you can do the same. And like battery, it needs 1 or 2 hours of charging. For an engine powered drone, you just have to fill the tank with petrol and you're good to go again. So these are some options, but engine powered has its own problem. So therefore people are exploring the hydrogen powered drones. Then autonomous taxis, you will see a number of this startups coming up right now which are working to make autonomous taxis so that they can fly from one place to the other and avoid the traffics. So these are number of startups coming up right now, and they are working on autonomous taxis that are basically drones, that is multicopters, which are in large size, so a passenger doesn't actually control the drone. The drone controls on its own, and it transports a person from one place to the other. Then there are shipping and delivery based options. So you want to order something from Amazon. Nowadays you have to wait for 5 to 6 days, or if you use this one aircraft option, then you'll have to pay more. So how do you go about it? How do you decrease the time of this thing as well as not increase the cost? So people are still exploring how to use drones. I think all of you have seen Amazon use drones to deliver its packages. Even some food based companies are also trying to see. Even Zomato is also trying to explore. Zomato, Swiggy is trying to explore the same thing to see if it can deliver food packages using drones. Then there are improved computer vision. So now you have a camera, but you want the drone to identify or maybe understand its environment. So for that you use some software so that it can understand and process those informations. So in this case, computer visions are used. Then environmental awareness. Nowadays, you will see many drones use the same. For example, the drone will understand in which environment it is. For example, there is a wall. The drone will itself decide that there is a wall in front of it and will react accordingly. So that it will make sure that the drone doesn't go forward and hit the wall, so that will happen without even you giving the instruction. So these systems are being used nowadays. Then drone warfare, like we have, there's tremendous market right now for drones in defense. It has been extensively used for drones sorry for extensively used drones for warfare. And then comes artificial intelligence, where various other applications where the drone has to take its own decision. Such thing has been explored and researched upon. So if you see the graph with respect to years, the consumption of drones has dramatically increased in the market. If you see compared to 2016 and the expected 2028, there is a big change in the graph. It's exponentially increasing. So you can just expect from what is coming ahead, what is the future of drones right now. So if you see the bottom graph also, you will see the evolution of how drone has changed with respect to years. With before, we just used to have balloons for the same, for some for a warfare or maybe for other experiments, everything. Then slowly we have been evolving from RC planes to then drones for military, that is sort of predators drones and everything. Then slowly you could see drones being used in various films and even various YouTube videos that you see nowadays. Then slowly people have Amazon tried to do the delivery, so that delivery market for drone has come ahead. So going ahead, you will see drones penetrate in many other applications. There is an enormous application of drones. So going ahead, you can definitely see drones penetrate into various applications and in the market. So you have a drone. How do you categorize it? I believe all of you know that the phones you have, there are some generation 4, generation 5. You have classified the following phones, that this is a generation 4 phone, this is a generation 2 phone, this is a generation 5 phone, something like that. So that is the same for drones as well. So you have a drone. What is the classification of this drone that you have? So if you see, these are the following 7 generations that a drone can be classified into. Let us assume you have a basic RC aircraft, that is basically a toy that you see, that you can classify it as a general generation 1 drone. Now you fit a camera, but that is for RC racing. That becomes a generation 2 drone. Then you fit a little better camera with some stabilization system, so that even when the drone is rotating, you get a stable picture. So you get a generation 3 drone. Now comes, you need a little more better camera system. Maybe it is used for basic surveillance or security purposes. Then you fit more superior camera with some better equipments, some safety modes also, and you have a stabilization system for that camera. You can categorize that as generation 4 drone. Then comes the cinematographic drones that is used for cinema. Then you have some intelligence system that is equipped with that drone, that you can classify as at generation 5. Then you see the more commercial and more advanced drones that are being used for industrial applications, maybe for this agriculture itself, or maybe for security police forces. Those are basically generation 6. And generation 7 is that those autonomous systems that basically needs no touching at all. It will do completely on its own, it will work on its own, it will take off land with basic instructions. So basically it's a very simple to use equipment, but very advanced. Basically it takes the decisions on its own. So those will be generation 7 drones. Now, what is the future of drones? You have seen the recent advancements, but what can you expect from the drone that is coming ahead? What is the penetration of drones where you can expect to see more drones being used? So, if you see from the graphs that you have, it definitely, like we discussed in the previous uh, graphs as well, you can see tremendous amount of drones flying around in the coming future. You will see many drones just running around on your head uh, in the coming future. Along with that, in which application you can expect to see more number of drones. Definitely photography is a very important sector, but along with that, defense plays a very important as a market for drones itself. You can see a big number of drones being used in defense. Other than that, photography and various other applications like agriculture, then scientific experiments, etc. So these are so you can expect drones as ambulances. Nowadays, the problem what happens is ambulance cannot reach a particular place at time, or there's a very critical situation. So how do you want to send a first aid, or maybe in a disaster system where there is no roadway to reach the place? So you send an ambulance drone where it provides the medicine and first aid in the right time, so that by the time the emergency forces reach the place, at least the critical patient can be addressed. Then you have warfare drones, where it's a big market that is coming. Basically, the future is you won't see army or any people fighting in the field. You will see basically cyber wars and wars with robots and everything. So nowadays, drones are being extensively researched upon for defense. Then, like taxi drones, even in Dubai and all, there have been various promotions for drones that can transport people from one place to the other. Then definitely delivery is something you can definitely see. You won't see a Swiggy person coming to your gate anymore. So the future will definitely be a drone coming to your gate and delivering your pizza or whatever it is. Then you have some drones, for example, Facebook is using drones, planning to use drones, have been experimenting on drones to see if they can increase the internet connectivity to remote areas, so that even the remote areas can access internet. So they are using drones for the same, so that they do not have to plant a tower or something, and without any environmental hazards, they can just keep a drone that can fly high in the sky and maintain the connectivity of that area. Then definitely agriculture is going to use, slowly people are moving away from agriculture, but definitely we humans need food. So soon we'll see robots and drones take over this complete area, and your food will be produced by technology in the coming future. So I hope I could give a brief overview of drones and how it has been used. Definitely, it's a very big field. It's a very big market. There are a number of companies, startups that are working in this field extensively. So definitely, you youngsters are there. If you ever want to explore this field, field is very vast. Each and every part has its own research and development. So whatever I gave in this webinar is definitely not enough, but is definitely a beginning of where you can start thinking upon what is the basic of a drone, what the drone, how it works, how you can classify a drone, who to go to register your drone. If you want to make your drone, what are the parts you will need, and if you in future you want to make your own startup or maybe join a company, or maybe you want to explore your own research. So what are the advancements that you can see in drones, or what is the future you can expect for drones? So this was the discussion that we had. This is what I have planned to discuss with you all. So definitely there are many things ahead. Many it's a big market. It's a very new market. It's still being explored. India is still very new to this market and is exploring extensively in the same. So we also have various rules and regulations for drones in India. So therefore, definitely, I hope this webinar is a initiation of your curiosity towards this industry. And definitely, if you want to explore more on this field, there's so much more sources out there, but at least you know where to begin with. So with that, I would like to conclude my presentation. And if you have any questions, you can let me know. Hello, I hope you can hear me.
Sir? Yes, sir.
Yes, if anyone has any questions or queries, they have any doubts.
Some doubts in chat box, sir. Just see the chat box.
One second. Okay, so
Other participants?
Rajat Kumar, is it? Yeah, Rajat Kumar has asked which microcontrollers is used in drones. So drones have like mostly in for beginners. Even you can use Arduino. There are various options for that. There are Pixhawk controllers. There are some ready-to-use flight controllers which has all this which are ready to use for drones. There are many other options as well. But if you go to the industry, mostly micro controllers are made by the company itself, or maybe a tie-up with various companies. So these are from the complex side. But for beginning, I think there's Arduino to go with, or maybe some ready-to-use flight controllers like Pixhawk, mostly used, and other controllers you will definitely get such sources. Okay, so how accelerometer works? So accelerometer works. If you have seen in that presentation, what happens is uh, an acceleration in a particular axis. There will be a sort of jerk. If you recall, let us assume you are sitting in a car. I accelerate the car in a particular direction, then definitely you will be pushed back. Or if I quickly press the brake, then you will say deceleration. So due to which you will be coming you will be just pushed at the front. So that reaction is being sensed by the sensor, using the mechanism that you have seen in this presentation. So a jerk in that axis is monitored by this uh, sensor, and that following information is given to the flight controller to understand in which direction it is accelerating, something of that sort. I hope I answered your question.
Participants have any doubts? If you have any doubts, you can pin your doubts in the comment box or chat box. Sir, I think no doubts in. Sir,
Oh, okay, yeah, yeah, yeah.
sir, can we end the session, sir?
Yes, I think if you have, I hope everyone here has enjoyed this session. I know there is a lot of things to still explore, but with this brief time, maybe they were able to learn a bit or two from this session. So with that, I thank you everyone for being here, and thank you Aero, uh, Wings of Aero, for having me here. Thank you. And Aravind, thank you very much for this opportunity. It was a big pleasure being here.
Thank you, sir. Thank you so much. That was very wonderful session. So thank you so much for delivering to such as a remarkably presentation, sir. It was very useful and give a curiosity, sir. Thank you very much.
Thank you.
So can we